go on with your presentation. Thank you.
Yeah, as mentioned, I will start by sharing my screen. So I hope that you can all see it. Yes, my name is Magnus Wallberg, and I work for the Uppsala Monitoring Center in Uppsala, and we are, as you mentioned, the WHO Collaborating Center. I present on the global alignment of substances and PhP based on the ISO IDMP. I hope that you can still see my screen. I get some pop-ups telling me that Zoom crashes, but I hope that it works. So IDMP implementation is a collaborative project, and one of the groups are the GIDWIG group, which is a global IDMP working group, and it has lots of members, as you can see on this screen. I am going to present what we are doing in this project. I will start quickly by just explaining what the PhP ID is and what the global substance ID is, and then I will go into how we reason about making those available on a FHIR format. So just to start with, the global PhP ID is a unique identifier on global level, which identifies substances, units of measurements, and pharmaceutical dose forms for medicinal products or parts of medicinal products. It can come on different levels, and the most specified level is level 4, which is the most important level. Then there are levels where you do not know the strength, dose form, and substance as well. The idea behind having a global PhP ID is that you should be able to uniquely identify the ingredients and the form and strength of medicinal products, no matter what the name is or what the manufacturer is in different countries. So here, for example, all those products would have the same PhP ID. It's the GIDWIG projects, it's a number of them. We talk about global dose form ID, global substance ID, strength definitions, and then we have a maintenance operating model for PhP IDs. And as I mentioned, we have also worked a lot with FHIR, HL7 FHIR for IDMP in order to leverage those. So we should start just by looking at the global safety identifiers, or JSIDs. The reason that we need them is that we have a number of different variants of describing substance globally, and they all come with their own coding systems and codes. The idea with the global substance identifier is that it should be globally unique, so that you can use that to generate and to uniquely identify from a PhP ID or pharmaceutical product identifier. In the GIDWIG pilot, we have defined the following structure for a global safety identifier. It starts with JSID, which uniquely identifies it as a global safety identifier, and it has a number of digits and then a check digit in the end. So when a new JSID is supposed to be generated based on an existing substance, we get data from the different stakeholders in this GIDWIG pilot. So those IDs that I will show you now, I should say, is just for pilot usage, and it's not the real PhP ID, or JSIDs that will be generated. If we can generate a JSID, we just generate it and publish it, and if we have issues with it, we have a GIDWIG expert team that solves those issues and makes assignment of JSIDs for substances. We follow a number of different standards. I won't go into those, but they are here for reference. Instead, I stop a little bit here, where we see how we generate the pharmaceutical product identifier, or PhP ID. As I mentioned, we need the JSID to start with that uniquely and globally identifies the substance. we need a conform way of identifying the strength and also conform way of identifying the dose. And the dose is made up by different parts. You have basic dose form, intended site, administration method, release characteristics, and so on. And those might slightly differ, even if it's actually the same thing. And that is one of the things that we do in this process of generating the PHP ID. We make sure that those conform to one dose form that can be used. The same goes with strength. It can be expressed in different ways in different regions and countries. And our main task there is to make those align with one way of expressing the strength. So given the JSID, the strength, and the dose form on those normalized formats, we can generate the PHP ID, which will then be the global identifier for this combination and this variant. There is a simplified workflow here, how a request works. And we have the request process where someone asks for a new PHP ID. We have a validation process, and then we generate the PHP ID and response with a new PHP ID or an existing one if the request comes in for something that's already been generated. Then, of course, we store this, and we have a publishing system that publishes those PHP IDs. And we have also, during the pilot, built a user interface where you can request single PHP IDs, batches, and also JS IDs. Now, as I mentioned in the beginning, my task at the UMC has been to look into how we can do this on a FHIR format to make it interoperable also in that sense. And if we start by looking at the FHIR standards, as part of FHIR version 5, there was an IDMP package, so to say. And the most important parts that we use in this IDMP area is a medicinal product definition, which identifies a product with name and market authorization holder. It has administrable product definition, which identifies substance, form, and strength, which actually is the PHP ID level. Then the administrable product definition contains ingredients, and the ingredients point out to the substance definitions, which are the JS IDs. It points out the global substance identifiers. And we will look a little bit more deeper into the substance definition and the APD. So if we look at the UMC SRS system, we have here an example of gosserelin acetate, which is a salt to the active moiety gosserelin. This is how it's shown in the user interface. And the corresponding FHIR resource, which is a substance definition, would look something like on the screen now. Everything isn't expanded, but you see the name, you see the JS ID, and you see also the relationship down on the bottom to the parent, so to say, or to the active moiety. This resource can be obtained through FHIR by just using the identifier as on top, but then you can also search for a JS ID using other coding systems like CAS, and you can search by name, and those are according to the FHIR standard, how you retrieve those resources. So, as I mentioned, we have a process of generating new JS IDs, and the process that I showed was the manual process that we have developed during the pilot. And the question is how you could do that using FHIR and using computer-to-computer communication instead. And the thing is that this is an asynchronous operation, since it will require manual intervention in the process. So you can't just ask a FHIR server to get the new JS ID. You have to request it and get back later for the answer. And that we can achieve using a FHIR task. I will go through this as fire resources in the beginning, and then I will get back and show it in a more summarized way that is slightly easier to understand. So a fire task contains resources on which actions should be performed. So in our scenario where we would like to request a new JS ID, we send a draft substance definition to the server embedded in the task. And we will then later get the task back with the generated JS ID as output. So this is how a task looks. It might be hard for you to read everything, but you see in the top you have a substance definition embedded in this task, which is a draft substance definition with an ID. And that ID then is the input for the task that it is supposed to work on. You take this task, the resource, and you post it to a server. And what you get back as response is a message. It's basically the same task with an ID and a status that it's been received. So this means that, okay, the maintenance organization has received the request for a new PHP ID, and it's bringing back a task. So it also contains header information about where you can ask for the progress in this PHP ID generation. So as I mentioned, it might take several days sometimes, and then the server needs to pull information back to see how the progress is. And if you follow that link that I have encircled, you will come to a page with a header that says what progress it is. Here it says ready. And then when you have asked and it's completed, you get the task back, which again has a status completed, but most importantly, it has the generated JS ID as output in the output section of the task. So there you see the reference to the newly created JS ID based on this substance definition resource that you sent in as a draft. So this is a substance definition then that's received through this link that you had as output. And there you see the identifier now with the newly created JS ID. So as a summary, what you do is that you create the substance definition with necessary information to be able to generate this JS ID. You embed that substance definition into a fire task, which you post to the maintenance organization. Then you pull for status upgrades on the task that you sent in. And when it's finished, you get the completed status, which means that we have published it and that you could retrieve it through a simple get. And that published version will be there for everyone to use. If we look at PHP ID requests, it's basically the same thing as requesting JS ID. The difference is that you have more information in order to generate the PHP ID. So you need the information about the medicinal product definition, you need the administrable product definition, which is a draft without the PHP ID, and you need the ingredients. But given that information, the process can take the information needed and generate the PHP ID and also connect it to medicinal product information that comes in the package. So the same process, you post it and then you do get requests to the maintenance organization. It's published when it's been generated, and then you can get it using a link to that administrable product definition. So a simple use case, assume that we have a Japanese product that has been sent to the maintenance organization to generate the PHP ID. So it's available in this global register. The thing is that in Japan, the user normally only have the Japanese identifier of this product. So since the information about the product is sent as part of the request for a PHP ID, we will be able to look up the corresponding PHP ID to this Japanese product. We do that by asking our FHIR server for an administrable product definition for this specific MPID, which is a Japanese MPID. That would retrieve the administrable product definition, which is then the PHP ID. And in the middle, you see the generated, the PHP ID that's assigned to this product. Now, as a second step, when you would like to know, okay, we had this scenario that we had the Japanese product and you wanted the corresponding US product. You have requested the PHP ID. Now you can ask for medicinal product definitions in this server using the PHP ID and specifying which country you would like to get those medicinal products from. When you send that query, you see that, okay, there is in total 11 products in US that corresponds to this PHP ID. In the entry, as you see in the bottom here, you get a list of them, and then you can move next if you would like to see all of them. So this is a paged bundle that you get as a response. And bringing up the first of those drugs in this list show you that, okay, the corresponding product in US for this Japanese product was actually Socor, which has the same form and strength and substances as the Japanese product that I was having in my, for example, prescription. So this use case shows how you, given MPID in Japan, can use that MPID to look up the corresponding global PHP ID, which in turn can give you the same products in US, which is connected to that PHP ID. Of course, in this example, the PHP IDs were stored in the maintenance organization in the FHIR server. The PHP IDs can, of course, also be stored in the local systems, and then there would be no need for this extra lookup. But that depends a little bit from system to system and region to region how that is solved. This is at least one example of how it could be solved. So that was a short summary of the GIDWIG project from the Uppsala Monitoring Center side, and also the work that we have done on making this a reality also on the FHIR standard. As I mentioned, it's so far just a pilot, and we will continue working on this during the autumn and beginning of next year. So I think that I stop there and leave up the floor for questions.
Is it working? Yeah. Thank you, Magnus, for this. I mean, you have proven you have put your hands into the weeds. Yep. So we have time for maybe one or two questions. Are there some questions of the audience? I think you have struck everyone down with this technical knowledge. No, thank you.